Okay, next let's go to the actual configuration of this feature. So looking at our switch in here, at our diagram in here, we have router 1, which is pre-configured as a server. So this is pre-configured as a DHCP server, and PCA is pre-configured as a DHCP client. So before we configure snooping 0911 on the switch, let's confirm that the an address has been assigned by the server to the client, and IP connectivity works in there. So router 1, if we say show IP DHCP binding, it has assigned this value, this IP address. This is the IP address it has assigned to this, what they state in there, to this client ID / hardware address, which is the MAC address, because it depends if the client identifier is present or not in the DHCP discovery from the client, or to that username, because that can also be the case, to assign an address based on the username. So the DHCP has successfully worked. If we ping the client, we're able to ping it. If we say debug DHCP detail and not undebug all, debug IP DHCP server, let's say packet and events, let's say clear IP DHCP binding all, and let's flap the PC's port per design. I'm sending a notification to the client. So let's go on the client's port. Let's flap the client in order to, so that the client is going to request again a new IP address, PCA. I'm going to say shutdown, and no shutdown. Let's make sure router 1 has logging debugging, because I saw this output in here. Let's give it a couple of seconds for the PC to come back up in the network to send a request. Show IP DHCP binding. Let's say show spanning tree interface FA105 to see it's in forwarding state, and it is. Let's say show MAC address table, because I have on this port connected both a phone and a PC. Show MAC address table dynamic interface FA105, and we have, this should be our PC. Let's go on PCA. There we go. So the server says we received the discovery packet, and in that DHCP packet, this was the DHCP client identifier of PCA. It is by default based on the MAC address, but it's not only the MAC address. 01 means it's going to be Ethernet connection, and that is over Ethernet. Then it's going to be the MAC address of the client in this case. So in this case, that Windows device uses a very basic DHCP client identifier derivation. The type of the connection and then the MAC address. So this is the DHCP client identifier. And also this is the MAC address in here. Let's say undebug all. And this is the MAC address of the client, which is contained likewise in the payload in the hardware MAC address in there. So of course it went to the discovery message, then it sent the offer message, sending offer, and then request from the client, and then acknowledgement somewhere. There we go. So in the show IP DHCP binding table, we have assigned an address to that client based on its DHCP client identifier, which by default, because it's a Windows system and it's an end user system, it contains also the MAC address. But again, this varies based again on the connection type, system type. It depends a lot. Either way, so DHCP worked. Now let's go on in there on switch 1 and reconfigure, then enable snooping on VLAN 11, which means by default this port is going to be both ports, both this one and this one are going to become untrusted, which DHCP should no longer work in this case. Let's go on switch 1 and we follow up on the steps. First of all, we say conft IP DHCP snooping globally enable the capability, and then per VLAN IP DHCP snooping VLAN 11. If we verify show IP DHCP snooping, then it states in here that it is globally enabled as a result of IP DHCP snooping command, and it was also configured for VLAN 11 as a result of IP DHCP snooping VLAN 11. So it's configured and operational for VLAN 11. And by default, option 82 injection is on, but the switch has seen nothing in there. There's nothing in the binding table because the DHCP allocation has happened before I assigned before I enabled DHCP snooping. Let's compare the binding location IP DHCP. So if you say show IP DHCP snooping binding, I see nothing in there because I enabled this capability after the client has been assigned an address. So it's an order of operation. Let's configure IP DHCP snooping database, let's say flash, on let's say snooping.txt. Yeah, ideally NTP, it depends how you save it, it's not a discussion, but either way it is succeeded, it created a file in there. So there flash, the file was created. Now in this case, if you say show IP DHCP snooping again, there is no trusted interface. So all of them are by default untrusted. So it means that now on router 1, which is my server, if I say clear IP DHCP binding all, and I shut the client again, it's not going to work because all interfaces are untrusted. If we say show IP DHCP snooping binding statistics, snooping statistics, not binding because binding is the table, it says currently no packets have been dropped from untrusted ports. And as you can see, the switch says, it's not a discussion, I don't have time to explain exactly what happens in here. But the thing is that it doesn't work. So the port is up, show spanning tree, interface, FA105. It's more of an advanced topic to explain everything in there. So the client port of PCA is in STP forwarding. It should request an address. But as you can see, on router 1 there is silence. There is nothing being assigned to the client. So let's go ahead and now let's configure it properly as we should. We have to go and put this port facing the DHCP server to be trusted. And then let's also go and put this port in here facing, so the untrusted port, because this is what you want to do. All untrusted port, you're going to configure rate limiting. So let's rate limit DHCP packets on untrusted ports to, let's say, 5 per second. So let's go back on switch 1, and the port facing my router is gonna be, I'm gonna configure it as trusted. Facing router 1 is port FA101. I'm gonna say clearly as the command is very simple: IP DHCP Snooping trust. And a port facing the client, IP DHCP, not relay, snooping limit rate. How many packets? 5, not more than 5. Or let's say 10, just to make sure it works. So now if we say again show IP DHCP snooping, we see now that FA101 is trusted, and because it's a trusted port, there's no limit on the packets per second because the server has to be able to speak as fast as it requires. Then on the client side, which clearly it's untrusted, the client side, it's untrusted, we have configured limiting of 10 packets per second. So now if we shut the client again, let's make sure that router 1 I have debugging turned on. Show debug. Debug IPDHCP server events and packets. Let's unshut a port. Give it a couple of seconds for the client to be able to send a DHCP request. Show spanning tree interface FA105. It is in forwarding state now for VLAN 11, and router 1 has received a request, but it complains about option 82 being in there, which means it's like a somebody relayed that DHCP packet, and as I said it by design, a relay should have been only a layer 3 relay, but now because it's a layer 2 relay, the router complains saying I'm going to ignore that request, something is wrong in there. So as I said, we have two options for this. We can either configure the router to accept the request or the switch to no longer inject option 82. Let me shut down again the client's port, shut down, and then let's make the switch not inject option 82, no IP DHCP snooping formation option. Let's confirm now show IP DHCP snooping. That insertion of option 82 is now disabled. Now let's unshut a port, and this time it should work successfully. Until this happens, I'm not sure if you have noticed that throughout the class, and in general throughout all my classes, I don't memorize commands, so I don't remember them. Based on how technology works and what I want to do, I just come up with a command. It should be there. So ideally, this is also should be your goal, not to memorize commands. So now the client has received, finally it work. Now again, show IP DHCP binding. I again allocated an address to the client. Not yet. Give it a couple of more seconds. Let's look on the client side again. So it should work in a couple. The client's address is show spanning tree interface the client's port. My PCA's MAC address. VLAN 11 show MAC address table. Show MAC address table dynamic interface FA105. It is this MAC address for my client. And pretty much in a couple it should work. Give it a couple more seconds. Let's try a shut again. This is a VM and it's a bit, let's say, lazy because it's a virtual NIC card. Let's make sure the porting is in forwarding stage STP wise. And there we go. Show IP DHCP binding. Not really. So inform received from the client, sending act to the client, broadcasting reply. So the client now doesn't reply for whatever reason. Okay, let's go. Let's do this. Let's go on the client and reload the client. It's going to be way faster. Shut down, reload. This is an issue on the client side. It's a VM. It's going to be very, very fast. Okay, so it looks better now, hopefully. And there we go. Let's make sure I can ping the client. But because it's a VM, it sometimes gets stuck in there. Just to confirm the client has that IP address, IP config. And there we go, it is that address assigned to the client in there. So as expected, it worked. And on the switch side now, we say show IP DHCP snooping binding. We should see that binding entry in there. So if that's this entry, it means this the switch says that this MAC address of PCA, the binding of this MAC address to this IP address, and the lease is that value was seen, it was done via DHCP snooping, and that's from VLAN 11, and the client is connected on port FA105. So you have only one binding, and of course show IP DHCP snooping database is going to show the location of the database where I have written that. So the location is as configured, and I had 2 attempts to write something in the database, and I have successfully written 2 of them. Directory flash snooping txt. I should be able to read that data. For whatever reason, it doesn't show up in this code either way. So you saw that it works.